Hi, everyone. Can you all hear me okay? I'm going to assume that that was a yes. Okay. So here's an overview of what I'm going to be talking about today. So first, I'm going to talk a little bit about why learning human values is difficult for AI systems. I'm then going to explain to you the safety via debate method, which is one of the methods that OpenAI is currently exploring for helping AI to robustly do what humans want. And then I'm going to talk a bit more about why I think this is relevant to social scientists and why I think social scientists, in particular people like experimental psychologists and behavioral scientists, can really help with this project. And I'll give you a bit more details about how they can help towards the end of the talk. Okay. So learning humans' values is difficult. We want to train AI systems to kind of robustly do what humans want. And in the first instance, we can just imagine this being what one person wants. And then ideally, we can expand it to doing what most people would consider good and valuable. But human values are very difficult to specify, especially with the kind of precision that is required of something like a machine learning system. And I think it's really important to emphasize that this is true even of cases where there's moral consensus or consensus about what people want in a given instance. So take a kind of principle like do not harm someone needlessly. I think we can be really tempted to think something like, well, if I have I've got a computer, and so I can just write into the computer, do not harm someone needlessly. But this is a really underspecified principle. Most humans know exactly what it means. They know exactly when when harming someone is needless. So if you're shaking someone's hand and you push them over, we think this is needless harm. But if you see someone in the street who's about to be hit by a car and you push them to the ground, we think that's not an instance of needless harm. So humans just have a pretty good way of knowing when this principle applies and when it doesn't. But for a formal system, there's going to be a lot of questions about precisely what's going on here. So one question the system might ask is, how do I recognize when someone is being harmed? It's very easy for us to see things like stop signs, but when we're building self-driving cars, we don't just program in something like, stop a stop sign. We instead have to train it to be able to recognize an instance of a stop sign. And then the principle that says that you shouldn't harm someone needlessly employs this notion of that we kind of understand when harm is and isn't appropriate. Whereas there's a lot of questions here, when is harm justified? What is the rule for all plausible scenarios in which I might find myself? These are things that you need to specify if you want your system to be able to work in all of the kind of cases that you want it to be able to work in. So I think this is an important point to just kind of internalize is it's easy for humans to identify and pick up, say, a glass. But training an ML system to do it requires a lot of data. And this is true of just a lot of tasks that humans might intuitively think are easy. And we shouldn't then just transfer that intuition to the case of machine learning systems. And so when we're trying to teach human values to an AI system, it's not that we're just looking at edge cases like trolley problems. We're really looking at core cases of how do we make sure that our ML systems understand what humans want to do in the kind of everyday sense. Okay. So one way of doing this is through human feedback. So there are many approaches to training an AI to do what humans want. So you might think that humans could, say, demonstrate the behavior, and then you realize, well, there's going to be some behaviors that's just too difficult for humans to demonstrate. You might think that they can say whether they approve or disapprove of a given behavior. But one of the concerns about training from human feedback, so learning from humans what they want, is that we have a reward function as predicted by the human, and then we have AI strength. And when it reaches the superhuman level, it becomes really hard for humans to predict, to be able to give the right reward function. So as AI capabilities surpass the human level, the decisions and behavior of the AI system just might be too complex for the human to judge. So imagine agents that control, say, we've given the example of a large set of industrial robots. That might just be the kind of thing that I just couldn't evaluate whether these robots were doing a good job overall. It'd be extremely difficult for me to do so. And so the concern is that when behavior becomes much more complex and just much more large scale, it just becomes really hard for humans to be able to kind of judge whether something is doing a good job. And that's why you might expect this kind of drop off. And so this is a kind of scalability worry about human feedback. So what we ideally need to happen instead is that as AI strength increases, the reward that's predicted by the human is also able to basically keep pace. So how do we achieve this? One of the things that we want to do here is we want to try and break down the kind of complex questions and complex tasks, like having all of these industrial robots perform like a kind of complex set of functions that comes together to make something useful, into some kind of like smaller set of tasks and components that humans are able to judge. So here is like a big question, and the idea is that the overall tree might be too hard for humans to fully check, but it can be kind of decomposed into these elements such that at the very kind of bottom level, humans can check these things. So maybe the example of how should a large set of industrial robots be organized to do task X would be an example of a big question where that's like a really complex task. But there's some things that are checkable by humans. So if we could decompose this task so that we were just asking a human, if one of the robots performs this small action, will the result be this outcome, this small outcome? And that's something that humans can check. And in the case of like what humans want, a big question is, what do humans want? Much smaller question, if you can manage to like decompose this, is something like, it's better to save 20 minutes of someone's time than to save 10 minutes of their time. So if you imagine some AI agent that's there to like assist with humans, this is like a fact that we can definitely check, even if I can't answer my assistant, like this like assistance AI, I can't say something like, this is just what I want. This is like everything that I want. I'm not able to like tell it that. But I can tell it that I'd rather it save 20 minutes of my time than it save 10 minutes of my time. Okay. So one of the key issues is that with current ML systems, we need to train on a lot of data from humans. So if you imagine that we want humans to actually give this kind of feedback on these kind of like ground level claims or questions, then we're going to have to train on like a lot of data from people. So just to give some examples, simple image classifiers train on thousands of images. Like these are the ones you can kind of like make yourself, and you'll see the data sets are pretty large. AlphaGo Zero played nearly 5 million games of Go during training. OpenAI 5 trains on 180 years of Dota 2 games per day. So this gives you a sense of like how much data you need to like train these systems. So if we're using current ML techniques to teach AI human values, we can't rule out needing millions to tens of millions of short interactions from humans as like the data that we're using. So earlier, I kind of talked about human feedback where I was like assuming that we were kind of asking humans questions. So something like we could just ask humans really simple things like, do you prefer to eat an omelet or 1,000 hot dogs? Or is it better to provide medicine or books to this particular family? One way that we might think that we can get kind of more information from the data that we're able to gather is by finding reasons that humans have for the answers that they give. So if you manage to learn that humans generally prefer to eat a certain amount per meal, you can kind of rule out a large class of questions you might ever want to ask people. You're never going to ask them, do you prefer to eat an omelet or 1,000 hot dogs? Because you know that humans just generally don't like to eat 1,000 hot dogs in one meal, except in very strange circumstances. And you also know facts like humans prioritize necessary healthcare over mild entertainment. So this might mean that if you see a family that is desperately in need of some medicine, you just know that you're not going to say, hey, should I provide them with like an entertaining book or this like essential medicine? So there's a sense in which when you can identify the reasons that humans are giving for their answers, this kind of like lets you go beyond and like learn sort of like faster what they're going to say in a given circumstance about what they want. It's not to say that you couldn't learn the same things by just asking people questions, but rather if you can find a quicker way to identify reasons, then this could be like much more scalable. So debate is a kind of proposed method for trying to learn human reasons that like is currently being explored. So to give you the kind of definition of a debate here, so the idea is that two AI agents are going to be given a question, and they take turns making short statements, and a human judges at the end which of the statements gave the most true, valuable information. It's worth noting that this is like quite dissimilar from a lot of human debates. So with human debates, people like, they might give one answer, but then they might adjust their answer over the course of a debate, or they might kind of like debate with each other in a way that's more exploratory. They're gaining information from the other debater, which they're then updating on, and then they're like feeding that back into the debate. With AI debates, you're not doing it for information value, so it's not going to have the same sort of like exploratory component down like multiple paths. Instead, you would hopefully see the agents explore a path kind of like this. So imagine I want my AI agent to basically decide which bike I should buy. I don't want to have to like go and look up all the Amazon reviews, etc. In a debate, I might get something like, you should buy the red road bike from the first agent. Suppose that blue disagrees with it, so blue says you should buy the blue fixie. Then red says, the red road bike is easier to ride on local hills. And one of the key things to suppose here is that for me, this is, like I live in San Francisco, being able to like ride on the local hills is like very important to me in a bike. It might even overwhelm like all other considerations. So even if the blue fixie is cheaper by say $100, I just wouldn't be willing to pay that. I'd be happy to pay the extra $100 in order to be able to ride on local hills. And if this is the case, then there's basically nothing true that the other agent can point to convince me to buy the blue fixie. Then blue should just say I concede. Now, blue could have lied, for example, but if we assume that like red is able to kind of point out blue's lies, we should just expect blue to basically lose this debate. And if it's explored enough and attempted enough debates, it might just see that and then say, yes, you've identified the key reason, I concede. And so it's important to note that like we can imagine this being used to like identify multiple reasons, but here it's identified a really important reason for me, something that is in fact going to be like really compelling in a debate. Namely, it's easier to ride on local hills. Okay, so training an AI to debate looks something like this. If we imagine Alice and Bob are two debaters, and each of these is like a statement made by each agent. And so you're going to see exploration of the tree. So the first one might be this, and here the human say that the human decides that Bob won in that case. This is like another node, and so this is like the exploration of the debate tree. And so you end up with a debate tree that looks a little bit like a kind of game of Go. And so when we explore, like when you have AI training to play Go, it's exploring like lots of different paths down the tree. And then there's a win or loss condition at the end, and that's like its feedback. This is like how it's basically learning how to play. With debate, you can imagine the same thing, but where you're exploring a large tree of debates, and humans are assessing whether you win or not. And this is like just a way of like training up AI to get better at debate and to eventually, ideally, identify reasons that humans find compelling. Okay, so one kind of thesis here that I think is relatively important is this kind of like positive amplification thesis or positive amplification threshold. So one thing that we might think, or that seems fairly plausible, is that if humans are like above some threshold of rationality and goodness, then debate is going to like amplify their positive aspects. So this is like speculative, but it's like a kind of hypothesis that we're working with. And the idea here is that if I am like pretty rational and pretty well motivated, someone can then, if I am, suppose that I'm like looking at a debate, I might get some feedback of the form, actually that decision that you made was fairly biased, and I know that you don't like to be biased, so I want to like inform you of that. I get informed of that, and I'm like, yes, that's right, actually, I don't want to be biased in that respect. Suppose that they're like Kahneman and Tversky, they point out some like key cognitive bias that I have. If I'm kind of like rational enough, I might say, yes, I want to adjust that. And I give a newer kind of signal back in that's like has been improved by virtue of this process. So like if we're like somewhat rational, then we can imagine a situation in which like all of these like positive aspects of us are being amplified through this kind of process. But you can also imagine a kind of negative amplification. So if people are like below this threshold of rationality and goodness, we might worry that debate would like kind of amplify these negative aspects. If it turns out we can just be really convinced by kind of appealing to our worst nature, and like your system like learns to do that, then it could just like do that, feedback in, I become even kind of less rational and more biased, and that gets fed back in. So this is just like a kind of important hypothesis related to work on amplification, which if you're interested in, it's great, and I suggest you like take a look at it, but I'm not going to focus on it here. Okay. So how can social scientists help with this whole project? And hopefully I've conveyed some of like what I think of as like the real importance of the project. So first, I think that a key question here is kind of, it reminds me a little bit of Tetlock's work on like super forecasters. So like obviously a lot of social scientists have done work kind of identifying people who are like super forecasters, where they seem to be kind of like robustly more accurate than many people. They're robustly accurate across time when it comes to forecasts. And they work, we've found other features of them, like working in groups really helps, and so on. And one question is whether we can identify good human judges, or we can train people to become essentially super judges. So why is this helpful? This is just kind of one way of framing the ways in which social scientists could help with this project, I think. So firstly, if we do this, we'll be able to test how good human judges are and also see whether we can improve human judges. This means we'll be able to know if human, or at least try and find out whether humans are above this kind of positive amplification threshold. So our ordinary human judges that we would be using to judge debate kind of good enough to see an amplification of their good features is one question. Another question is, another reason to do this is that it improves the quality of the judging data that we can get. If people are just generally pretty good, rational at assessing debate, fairly quick, then this is excellent given the amount of data that we anticipate needing. Basically, improvements to your data can be extremely valuable here. So yeah, the benefits of this: positive amplification will be more likely during safety value debate, and also will improve training outcomes on limited data, which is very important. Okay. So this is one way of kind of framing why I think social scientists are pretty valuable here. But there's lots of questions that we really do want asked when it comes to this project. And this is just I think this is going to be true of other projects like asking human questions. It's basically to note that the human component of the human feedback is quite important, and getting that right is actually quite important. And that's something that we anticipate social scientists to be able to help with, more so than ML researchers who are not working with people and their biases and how rational they are, etc. These are questions that are the focus of social sciences. So one question is, how skilled are people as judges by default? Can we distinguish good judges of debate from bad judges of debate, and if so, how? Does judging ability generalize across domains? Can we train people to be better judges? Can we engage in kind of debiasing work, for example? Or work that reduces cognitive biases. What topics are people better or worse at judging? So are there ways of phrasing the questions so that people are just better at assessing them? Are there ways of structuring the debate that make them easier to judge? Or restricting debates to make them easier to judge? So we're often just showing people a small segment of a debate, for example. Can people work together to improve judging quality? So these are all kind of outstanding questions that we think are important. But we also think that they're empirical questions and that they have to be answered via experiment. And so this is, I think, important potential future work. So we've been thinking a little bit about what you would want in experiments that try and assess this in humans, how good are they at debating? How good are they at judging debate? Because ideally AI agents would be doing the debate in the long run. So one is just that there's a verifiable answer. We kind of need to be able to tell whether people are correct or not in their judgment of the debate. The other is that there is a plausible false answer, because if you have a debate, if we can only train on assess human judging ability on debates where there's no plausible false answer, we'd get this false signal that people are really good at judging debate. They always get the true answer, but that's because it's always just a really obvious question. Is it raining outside? And the person can look outside. We don't really want that kind of debate. Ideally, we want something where evidence is available so that it grounds out in, humans can have something that grounds out the debate. We also don't want debates to rely on human deception. So things tells in poker, for example, we really don't want that because AI agents are not going to have normal tells. It would be rather strange, I suppose, if they did. If you had stuttering or something. Debaters have to know more about the question as well, because the idea is that the AI agents will be much more capable, and so you don't want a situation in which there isn't a big gap, basically, between the debater capabilities and the judge abilities. Maybe these ones feel kind of pretty essential. These ones are sort of desires, I guess. So one is that biases are present. How good are humans when there's bias in their kind of, with respect to the question? There are representative segments of the debate that we can actually show people. The questions aren't too hard. It's just not impossible for humans to answer them. or judge debates about them. But they also mirror some of the difficulties of statistical debate, i.e. about probabilities rather than about outright claims. And finally, that we can get enough data. And so one thing you might notice is that there starts to be like kind of tensions between a lot of these desiderata. So that there's a plausible false answer is in a bit of tension with the idea that the question isn't too hard. If a question is like, and the same is true of like the question isn't too hard and the question mirroring statistical debate. Statistical debate is generally pretty hard to evaluate, I think, for people. And also, like, but also, like, quite important that we be able to model it. The debaters knowing more and that we can get enough data is, like, another thing. It's just harder to kind of train if we need debaters that, like, know a lot more than judges. And it's harder for judges to evaluate debates of this form. Okay, so I'm going to show you a debate. This is just to give you some of the difficulties, I guess. So this was a program set up where we would show a judge a kind of blank screen. So imagine you're not seeing the dog that's here. Two human debaters, sit in the same room, and they have this picture of a dog in front of them. And one of them is selected to lie, and one of them is selected to tell the truth. And what they can do here is they can select areas and describe to the human judge what they see in that area. And all that the judge is going to see is kind of their blank screen with like the relevant section selected. And then they can each make claims about what is in that section. So here red is saying it's a dog, here's its long floppy ear. Blue is saying no, here's one of its pointy ears, so it's trying to point to a smaller area where it looks kind of pointed. That does look like an ear slope to the right, but if it really was, then part of the head would be here. Instead, there's a brick. The ear is pointing out from behind the bricks. The dog is in front of the bricks. If it were behind, there would be an edge here, but the rectangle is all the same color. And then you get like a resignation. And at the end of the debate, they can show like a single pixel. And the question was something like, if all you can do is have a debate and show a single pixel, can you like get people to have accurate beliefs about the question? And basically, we saw like, yes, like debates were like fairly good in this kind of case, but you might think that this is like pretty synthetic. So one of the things that we're kind of thinking about now is like expert debaters with a lay judge. So I'm going to show you something that we did that's kind of fun, but I never know how it looks to outsiders. So we had a debate that was of this form. So this was a debate actually about quantum computing, where the idea is that we were going to debate this question. So we have two kind of, we say experts, but people who understand the domain. One of them is going to lie, one of them is going to tell the truth. So we had blue say red's algorithm is wrong because it increases alpha by an additive exponentially small amount each step, so it takes exponentially many steps to get alpha high enough. So this was like one of the kind of claims made. And then you get this set of responses. I don't think I need to go through all of them. You can see like kind of the form that they take. But it grounds out in this like claim so we allowed like certain restricted claims from Wikipedia. So blue ends this with the first line of this Wikipedia article says that the sum of probabilities is conserved. Red says an equal amount is subtracted from one amplitude and added to another, implying the sum of amplitudes are conserved, but probabilities are the squared magnitudes of amplitudes, so this is a contradiction. So this is, I think, roughly how this debate ended. But you can imagine this is like a really complex debate in a domain that the judges, like, ideally just won't understand and might not even have some of the concepts for. And that's the kind of difficulty of debate that we've been looking at. And so this is like one thing that we're kind of in the kind of early stages of prototyping. And thus far, I think it seems to be the case that people actually do update in the kind of right direction, but we don't really have enough data to like say for sure. Okay, so I hope that I've kind of given you an overview of like places and just even like a kind of restricted set of places in which I think like social scientists are going to be important in AI safety. So here we're interested in like experimental psychologists, cognitive scientists, and behavioral economists, so people who might be interested in actually scaling up and running some of these experiments. If you're interested in this, please come to my office hours after this talk or email me because we would love to hear from you. So thanks.
All right, we don't have too much time for questions, but if you want to sit, we can take a couple. Just for starters, as I was kind of watching this, I'm wondering how much of this is real at all or coming from an actual system versus like, do you have humans sort of playing the role of the agents in these examples?
Yeah, so like at the moment, the idea is that we want ultimately the debate to be conducted by AI, but we don't have like the language models like that we would need for that like yet. And so we're using humans as a kind of proxy to like test the judges in the meantime. So yeah, all of this is like done with humans at the moment.
So you're faking the AI to set up the scenario to train the judges to evaluate the judges on their ability to later provide feedback.
And some of the ideas, like I guess you don't necessarily want like all of this work to kind of happen like later, and once you like a lot of this work can be done before you even have the relevant capabilities to like have AI perform the debate. So that's why we're using humans just now.
Yeah, totally understood. Let's see, a couple questions coming in. I guess one note also for the audience, if you didn't see Jan Leka's talk yesterday, he showed some examples from the work that his team has done on video games that very much matched the plots that you had driven or that you had shown earlier, where up to a certain point, the behavior sort of matches the reward function.
Yeah.
And then at some point they sort of diverge sharply as the agent kind of finds a loophole in the system. So that can happen even in like Atari games, which is what they're working on. So obviously it gets a lot more complicated from there. So questions from the audience. How would you train, in this approach, you would train both the debating agents and the judges. So in that case, who evaluates the judges and based on what?
Yeah, so I think it's kind of interesting where we want to like identify how good the judges are in advance, because it might be hard to assess. Like later you could, if people are just judging on verifiable answers, you could in fact presumably assess the judges as you like, even when you're like doing training. But they're going to be, here we can kind of ground out debates in questions with like verifiable answers. Ideally, you want it to be the case that at training time, I think you've already identified judges that are like fairly good. And so ideally, this is part of this project, is to kind of like assess how good judges are prior to training, and then during training, you're giving the feedback to the debaters. So yeah, like ideally, some of that evaluation can be kind of front loaded, which is what a lot of this project would be.
Yeah, that does seem necessary as a casual Facebook user. I think the negative amplification is more prominently on display.
Or at least more concerning to people, as like a possibility.
Kind of a related question, how will you crowdsource the millions of human interactions that are needed to train AI across so many different domains without falling victim to trolls, lowest common denominator, et cetera?
Yeah.
The questioner cites the Microsoft Tay chatbot that sort of went dark pretty quickly.
Yeah, so the idea is you're not going to just be like sourcing this from like anyone. So if you identify people that are either good judges already, or you can like train people to be good judges, these are going to be the pool of people that you're kind of using to get this feedback from. So even if you've got like a huge number of interactions, ideally you are like, you're kind of like sourcing and like training people to be really good at this. And so you're not just like being like, hey, internet, like, what do you think of this debate? But rather like, okay, we've got this set of like really great trained judges that we've like, identified this wonderful mechanism to like train them to be good at this task. And then you're getting lots of feedback from that large pool of judges. So it's not kind of like sourced kind of to anonymous people everywhere, but rather like you're kind of interacting fairly closely with this set of people who are giving you lots.
But at some point, you do have to kind of scale this out, right? I mean, in the bike example, it's like there's so many bikes in the world and so many local hills.
Yeah.
So, I mean, do you feel like you can get a solid enough base that sort of becomes not a problem, or how does that?
Yeah, I think there's going to be like a trade-off where you need a lot of data, but ultimately, if it's like not great, so if it is really biased, for example, it's not clear that additional data is going to be like helpful. So if you get someone who's just like massively cognitively biased or biased against groups of people or something, or just like is going to be like dishonest in their judgment, this is not going to be like, it's not going to be like good to get that additional data. So you kind of want to scale it to the point where you're still getting like good information back from the judges. And that's why I think in part this like project is really important, because if you like one thing that social scientists can help us with is kind of identifying like how good people are. So if you know that people are just generally fairly good, this like gives you a bigger pool of people that you can appeal to. And if you know that you can train people to be really good, then this is like, again, a bigger pool of people that you can appeal to. So yeah, it's like you do want to scale, but you want to scale kind of within the limits of still getting like kind of good information from people. And so like ideally this would do this mix of letting us know how much we can scale and also maybe helping us to scale even more by like making people better at this like quite unusual task of judging these kind of debates.
So we are a little over time. Won't have time to go through all the questions that are coming in, but you can speak with Amanda more at office hours immediately following this talk, right, when we're headed into break. So let's just do one last question for this session, which is, how does your background as a philosopher inform the work that you're doing here?
Yeah, so I mean, I have, I guess, a background primarily in like formal ethics, which I think makes me sensitive to like some of the issues that we might be worried about here, like going forward. So, you know, people think about things like aggregating judgment, for example. Strangely, I found that like, you know, having backgrounds in things like philosophy of science can be weirdly helpful when it comes to like thinking about experiments to run. But for the most part, I think that my work has just been to kind of help prototype some of this stuff. I see the importance of it. I kind of like, I'm able to like foresee some of the kind of worries that people might have. But for the most part, I think we should just like try some of this stuff. And I think that for that, it's really important to have people with like experimental backgrounds in particular. So the ability to like run experiments and analyze that data. And so that's why I would like to kind of like find people who are interested in doing that. So I'd say philosophy is pretty useful for some things, less useful for running social science experiments than you might think.
All right, well, for more, you'll have to come to office hours, which you can do immediately after this session. How about a round of applause for Amanda Askell?